In this video, we're going to be going over some example questions on how much the heat changes, mainly in questions where we're melting, freezing, boiling, or condensing our substance. So if you take a look at the top of our worksheet here, there's a lot of important notes. I want to make sure you guys read through that. Here are our three different equations that we can use to determine the amount of heat needed. We have our top equation for a temperature change. And the main equations we're going to be using today are equation number 2. We have the equation we'll use during a phase change between a solid and a liquid. And we'll be using equation number 3. And that's for a phase change between a liquid and a gas. And you may notice there, we have this delta enthalpy of fusion. That's because we said that solids, liquids, and gases, they each have a different amount of enthalpy. And as it goes from a solid to a liquid to a gas, that enthalpy changes. And it's different for each substance. So the enthalpy of fusion is the amount of enthalpy a substance gains as it goes from a solid to a liquid. And the enthalpy of vaporization is the amount of enthalpy that changes when a substance goes from a liquid to a gas. Now we have to take into consideration here whether it's going to be absorbing that energy. So if it's melting or boiling, it'll be positive change because it's absorbing the energy. But also if something's freezing or condensing, that'll be exothermic because it's releasing the energy. So we're going to have a negative change there. So let's jump directly into some of these questions and look at how we're going to solve them and some keywords we're going to be looking for. So in question number 1, how much heat is needed to melt 45 grams of ice at 0 degrees? So we know that ice melts at 0 degrees, so it's already at its melting point. There's no change in temperature here. And because it says melt, we're going to be using our equation, Q equals mass enthalpy of fusion. So you could also even look at the top right here. If it's melting, that's enthalpy of fusion. So it should be pretty easy to always find mass directly in the problem. We got 45 grams here, so we'll write that down. Mass is equal to 45 grams. But we really need to know our enthalpy of fusion. Enthalpy of fusion, it's different for each substance. And luckily we have this table, and this is linked directly in the Google Classroom under the same assignment. So you can use this table. All of our enthalpy of fusions for all our different substances will be right here, all the way down. And we're just dealing with water here. So right at the top, our enthalpy of fusion is 334. I really want you guys to pay attention to this. Enthalpy of vaporization and enthalpy of fusion, they're very different numbers. It's always going to take more energy to bring something from a liquid to a gas than to bring something from a solid to a liquid. So we're using enthalpy of fusion here because we're going from a solid to a liquid. So 334 joules per gram. And then these equations here, it's always going to be just multiplying the mass by our enthalpy, our change in enthalpy. So Q equals 45 grams times 334 grams, 334 joules per gram. And our answer is going to equal, just multiply those in the calculator, 15,030 joules. So let's do a few more. I really want you guys to get the hang of this. Let's jump into question number 2. How much heat is needed to freeze? So that's a keyword we're going to be using. Freeze 45 grams of water at 0 degrees. Again, that 0 degrees is telling us we're already at the freezing point. There's no change in temperature. So I want us thinking, what equation are we going to use? Q is equal to no change in temperature, so it's not going to be number 1. If we take a look at number 2, are we melting or freezing? Yes, we are freezing. that means we're using change of enthalpy of fusion. So same equation as last time. And in fact, we even have the same mass as last time. So mass equals 45 grams. And believe it or not, we're still dealing with water. So if you take a look, and no matter whether it's water or ice, it's the same thing, it's going back and forth. We're gonna have that same enthalpy of fusion. So our enthalpy of fusion is gonna be 334 joules per gram. So when we plug everything in, there's only gonna be one thing that's different this time, and I want you to be very careful that you catch it. Our mass stays the same. Our enthalpy of fusion, because we are freezing, we're releasing that. So it's exothermic, so we have to use a negative enthalpy of fusion. So it'll be negative 334 joules per gram. And our answer is going to equal, let me write this here at the bottom, negative 15,030 joules. And this makes perfect sense because the law of conservation of energy states that we can't create or destroy energy. So it takes the same amount of energy to melt that ice as to freeze the ice. Just one case, you're absorbing it and melting, and in freezing, you're releasing it. So let's do a few more. Let's do question number 3. How much heat is needed to boil? So let's look at that keyword. We got boil here. 45 grams of water at 100 degrees. And 100 degrees is the boiling point. So that's telling us there's no temperature change. It's already there. It's already boiling. So our Q is going to equal, let me show you guys the problem we're working on here. All right, so our Q is going to equal, there's no temperature change, so it's not number 1. It's not melting or freezing, so it's not number 2. It is boiling, so we're going to be using mass times our change in enthalpy of vaporization. And we just need our mass here, 45 grams again, straight from the problem. And our change in enthalpy of vaporization, we're going to get from the table. So you can see right here, enthalpy of vaporization. And again, that's the definition of this, is the enthalpy needed to go from a liquid to a gas. So for water, it's 2,260 joules per gram. And then when we're trying to solve these, let me write it over here so I got some room. Q is going to equal the mass, 45 grams, straight from the question, times our enthalpy of vaporization. So 2260 joules per gram. Boiling is endothermic, so it's going to be positive. So my answer will be a positive number. It'll be 101,700 joules of energy to boil that 45 grams of water. Let's jump to one of the questions on the back here. Let's do question 7, then we'll jump to question 9. So question 7, how much energy is required to melt 83.1 grams of iron at its melting point? All right, let's write an equation here. So it's already at its melting point. There's no change in temperature. So Q is equal to mass, and we're melting here. So always pay attention to what we're doing. So we're melting. So we're going to be using our change in enthalpy of fusion. So let's start plugging things in. We have our mass here, 83.1 grams. 83.1 grams. And now we just need to plug in our enthalpy of fusion for iron. So let's look through our table. Look for iron. There it is, near the bottom. This is our specific heat. enthalpy of fusion will be right down here. 209 joules per gram. So times 209 joules per gram. Lastly, we got to think melting. Is that absorbing energy or is that releasing energy? So melting, it needs to absorb that energy, so it's positive. Multiply our two numbers, and we should get about 17,368. If you round it, we can go up. We can round it up to 17,400 joules. So don't worry too much about that rounding part, as long as you get a number like this and do it correctly. Lastly, we'll work on question number 9 because that asks us to compare some numbers. And we're just going to be doing very similar things. So it asks us to compare which one takes more energy, melting 126 grams of copper at its melting point, so no change in temperature, or boiling 4 grams of copper already at its boiling point. So we got to find these two answers and then we can compare them. So for melting, we use our change in enthalpy of fusion. For boiling, we use our change in enthalpy of vaporization. So those are going to be the two equations that we use. This is melting. This one's boiling. Notice that our masses are both different here. So we got to plug in our different masses. So for this one, we have a mass of 126 grams. For our boiling question, we got a mass of just 4 grams. So we would be melting a lot more than what we're boiling here. Now we have to use our table to find our change in enthalpy of fusion and vaporization. So let's jump over here. Copper has a enthalpy of fusion of 207. So let's mark that down before we forget. 207 joules per gram, and it's melting, so it is endothermic, it's positive. The enthalpy of vaporization would be 5,069. And boiling is also endothermic, so it's positive. So let's find our two numbers here. So I'm getting my calculator out. For our melting, it'll be 126 times 207 joules per gram. We'll get about 26,082 joules. To boil 4 grams of copper, let's see how much energy that takes. 4 grams times 5,069, 20,276 joules. We got to compare both of them, and it takes more energy. To melt 126 grams of copper. So our answer would be it takes more energy to melt the copper here. I'm hoping this helped. Again, if you want to go through, make sure to have this information here in your notebook. I guess all this information here in your notebook, because it'll be very useful to solve these problems.